So for today, what I thought we would do is we would go over some of the stuff that we had on Canvas real quick. And then we're going to break into some groups, and y'all are going to work a little bit on your traditional and non-traditional careers, what you've discovered. So you'll be able to talk amongst each other, share notes, probably spend a few minutes doing that, and then we'll break out into discussion about what you discovered there. And then we have a guest coming at about 9 o'clock, so in about an hour, to talk about competitive programs, which were also some of the things that we had in Canvas today. And so I want to talk a little bit about that before she arrives as well. So we have a full morning ahead of us. So since the last time we met, there was a pretty nice development in the Nobel Prize, which gets announced every fall in chemistry. Finally, John Goodenough got his Nobel Prize, right? And we talked about him at the beginning of the semester, kind of gave him as an example of not really an alternative career, so to speak, but in a way it is, right? I mean, he started off studying mathematics and then ends up being a meteorologist and then ends up coming back and studying physics, starts at MIT for a while, goes to Oxford, then comes back to the United States, where he's been since, I think, 1986 or 1987, something like that, in Texas. And so I would say that he has had kind of an alternative career, but nonetheless ultimately ended up with the highest prize one could obtain in the sciences, which is the Nobel Prize, in this case in chemistry. And I find it kind of interesting that Dr. Goodenough isn't even in a chemistry department, right? He's in a mechanical engineering department at Texas and has always been associated with materials engineering and that kind of work. Did a lot of stuff while I was in Massachusetts that actually led to what we know now today as random access memory, or RAM memory, what you have in your watch, your phone, your computer. Started with that and then moved on into the battery world. So how has, let's just think broadly, how has the Nobel Prize impacted each and every one of you? The work that they did, not the prize itself, right? Nobody gets to share in the millions. Your cell phones, every one of you probably have a cell phone on you right now, right? And would we have, if you watch the videos, would we have this mobile technology without lithium-ion batteries? We probably wouldn't, right? At least not as we know it. And why is that? I mean, we had cell phones in the 1980s. What all of a sudden made, what's the difference? That's right. That's right. It really comes down to size, right? So if you've ever seen an old movie where you see those old phones from the 1980s, early 90s, a lot of people referred to them as bricks. And a huge chunk of that weight was the battery. They were lead acid batteries or nickel cadmium batteries, and they were really, really heavy. And so when you're devoting a lot of space and time and energy just to the power source, you're not able to devote space, time, and energy to the technology itself. And so as the battery got smaller and smaller, so did the technology. And now that we have this in our hands, we have access to the internet all over, I mean, just practically everywhere, right? So it really has been a game changer. The power source really led to the revolution in the technology. So I'm happy to see that for Dr. Goodenough. Happy to see that somebody we actually talked about at the beginning of the semester ended up getting the prize. So it kind of makes it a full circle kind of thing for us, right? Which is kind of cool. And then, of course, two other scientists who shouldn't go unnamed, but we're not going to talk about them because we really spent a lot of time talking about Goodenough, and because I wanted you to see that you can actually start in one place and end up in a different place in a career trajectory. It's not always a straight line. And so life got in the way. You know, World War II got in the way for him, so to speak. He served and did all those things that his generation did, and then ultimately, you know, ended up in a place where he could get a Nobel Prize in chemistry. So I find that pretty remarkable. So we had the 40, 45-minute, whatever it was, video on the Nobel Prize. I wanted you all to see that, to see exactly how they make these announcements. What did you take away from that announcement, other than it was a big deal, a big occasion? There were reporters from all over the world there to hear the announcement. But I think, for me anyway, one of the things that's kind of exciting about those announcements is they really are mini classes, right? They actually talked about the technology that was developed and gave you the history of what was being developed. Every year this happens in all of the Nobel Prizes. You know, so if you really want to learn a tidbit about a long body of work, I mean, Goodenough and Whitman and the other one, they have published countless papers, but in general they gave you an overview in about 40 minutes of why it was significant and why it was important, right? And so you should have learned a little bit of chemistry from that as well, right? You learned that lithium cations, right, are what are responsible for the lithium ion battery. There's actually two types of lithium batteries. When you all go buy a Energizer lithium cell, is that a lithium ion battery? It is not. It actually has lithium metal in it. And they talked to you a little bit in that video about the hazards of lithium metal containing batteries, and what kind of were they? Anybody know? In any of the videos, they talked a little bit about the lithium metal issue. It is an explosive metal. It's actually not as reactive as they made it out to be. You can take lithium and you can throw it in water and it will fizz. And if you throw enough in there, it will actually burst into flame with the hydrogen that's released. It's not as reactive as sodium or potassium, but it is a fairly reactive thing. And so if you have a battery at home that gets punctured, one of those lithium batteries, it will burst into flames eventually. It will get enough heat generated that it will burst into flames. And so there's usually a warning on those lithium batteries, I should say, about puncturing them. Now, the lithium ion batteries do generate lithium inside that material, but that material kind of protects it and keeps it from being as exposed. And so as you all are in your general chemistry class learning about the different pieces of the periodic table right now and the different topics. What topic are you all talking about right now in Gen Chem? Thermo? Okay, so you're talking a little bit about thermodynamics. So obviously, when you throw lithium into water, it generates a lot of heat. That's thermo. I mean, so there is some connection there. But anyway, I find it pretty interesting how they go through and take a body of work that is many decades in the making and condense it into about 30 or 40 minutes of talking and do that. And that's one of the things that as you progress as scientists, you will find that you have to do. PhD students, for example, research students who do an awful lot of research, find it very, very, I won't say depressing, but it's the only word I can think of right now. It is kind of depressing. You do all this work for your PhD, 4 or 5 years of hard work, and you condense it down into about a 35, 40-minute talk, maybe 30, 40 slides, and it looks like to the audience that you probably did that over a couple of weeks. I mean, if you looked at those presentations, you would think, oh, that didn't take them very long to do, right? They figured all this stuff out, and that's just how it works. A couple of pictures. But that was decades of work being condensed down into a very short period of time. And that's one of the skills that you're going to learn in your research course when you get to your capstone, is how do you take a semester or 2 semesters worth of research and condense it down into a 12-minute talk. And you will leave from that going, man, it should have been more. And there was a lot more, but you have to condense it down into what the meat is, right? I also gave you the Goldwater Scholars link. Let's see if it opens up in the window here. So as I mentioned, we're going to have somebody come and talk to you today about these competitive programs. But one of the things that I wanted you to do in that link was kind of explore it. What did you find out in your exploration of the Goldwater link? Just by perusing the site, what did you find out? Okay, they've increased the number of scholarships. What else have you learned? Is this just a regular award? What is it? It's a highly competitive award, right? This is something that not everybody gets, even individuals who score very, very well. It turns out that each institution can only submit a handful of applications every year. And so there's actually an internal competition that has to happen before we decide who even is going to represent us at the institution. So I've served on the Goldwater committee here at this institution for a number of years. I'm no longer on it. But, you know, we would get anywhere from 8 to 9 applications, and we were only allowed to submit 4. All 8 or 9 were probably worthy of going forward in some form or fashion, but we had to look at those and determine who would be our best choices to move forward. And so it's a competitive process even before it gets to Goldwater. And then when it gets to Goldwater, it's still a further competitive process. This is probably the most prestigious undergraduate research award in the United States, in my opinion, especially for the STEM areas. There may be other awards in other disciplines that I'm just less aware of, but this is certainly kind of the gold standard. It was established by Congress in honor of Barry Goldwater, congressman. And so as you look through this, you know, you will find a variety of different links that you can look at. You can actually go in and see who won across the various states. Did anybody click on that one? Look at that link. If you'll go in and click on that link later, you'll find that for the state of Mississippi last year, I believe we had 4 total scholars, 3 of which were from USM. USM has led the state of Mississippi over the last decade in Goldwater scholarships. So, and why is that? In my opinion, it's because we actually spend an awful lot of time with our students here to develop them into Goldwater scholars. So we've had a large number of Goldwater scholars from chemistry, biochemistry, a couple from physics. I can't remember if we've had any from math. But and a couple from biology. So we've had a good number of Goldwater scholars over the last several years. We've led the state. In many years, our entire state Goldwaters have been such that USM really looks dominant on that web page. In fact, we have more Goldwater scholars at this that have come from this institution than all other Mississippi institutions combined. So we're very, very proud of that. If you look on the Goldwater site right now, you'll find that there were none of them this past year from Ole Miss. I think Mississippi State had 1 and we had 3. None of the other institutions had them. And so as you start to get involved in your research, you can begin to develop that into a Goldwater application. So that's one of the things that we do very well. We encourage you all to get involved in those research activities earlier than what is required for your capstone. You can't be a capstone student and qualify for a Goldwater. That would be the end of your term. But you can use your Goldwater research as part of your capstone. So a lot of students will start off in their sophomore year, and sometimes even earlier, doing research, taking Chemistry 392, which is introductory research, which can be counted as a general elective for you. You can go ahead and get involved, get to know a mentor, get to have a project that's underway, and then we can develop that into a nice Goldwater application for either the end of your sophomore year or the beginning of your junior year. The Goldwater Scholarship does provide money to help you pay for your tuition, so it is an excellent opportunity to help cover the costs of your education. And one of the videos that I had you watch on this alternative career paths video, and we're not going to watch it here because it's 50 minutes long, but it was by the Barry Goldwater Foundation, right? And so you had several individuals. I know you can't see them very well on the screen, but these are individuals who all won a Goldwater scholarship in the past decade or so. and then ultimately decided to take alternative careers in their lives, and for a variety of reasons. And so, but I think the thing that you saw from all of them is that Goldwater Scholarship, although they're no longer bench scientists, if you will, for the most part, that Goldwater Scholarship gave them the leg up to be competitive in all of their fields. I mean, you had some now basically running a brokerage firm or an equities broker. We have a postdoctoral researcher at the U.S. Naval Laboratories, which is a little, I wouldn't say that's terribly non-traditional or an alternative, but a little bit. You've got somebody who, more biology, somebody who's a principal scientist at a startup company on machine learning, and then somebody that that works at Wells Fargo. I mean, that's quite a deviation from traditional physics. So what I want to do right now, without talking about the other things right at the moment, I want you all to break up into, let's see, how many we got here today? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So break up into about 7 and 7. So 1, 2, 3, 4, 5, 6, and you'll be 7. So you all get together in one group and share notes about what you learned about both your traditional careers and your non-traditional careers for chemistry and biochemistry, and the other 8 of you, because 15 can't be evenly divided, get together over here and talk for about 15 minutes about the things that you found on the alternative careers and the traditional careers. And then we will come together and we will report out as groups. Kind of move your chairs, form a nice group that you can work in. Okay. Let's get out of group mode or discussion mode in the group anyway. You're still gonna report out as groups. So we're gonna have some traditional, and we're gonna have some non-traditional career paths. And so I'll start with this group over here. You can pick either traditional or non-traditional. It's just whatever comes to mind first. What were one of the things that you came up with? Nanotechnologist. I'll just abbreviate that as nanotech. What is a nanotechnologist? Let's start. What do you all think a nanotechnologist would be? Pardon? The nanobots? Okay. All right. Yeah, absolutely. There's nanotechnology. Anybody know what nanotechnology really is? What does nano mean? Yeah. I mean, you've learned in general chemistry about a nanometer, and right? So it's things that are on the extremely small scale. So everything that is extremely small must be nanotechnology, right? No, it is not. And that is a common misconception. In fact, you will find that a lot of papers or a lot of talks where they talk about nanotechnology really isn't nanotechnology, okay? Nanotechnology is where you get to a small enough scale that quantum effects start to dominate the properties of whatever it is that you're studying, okay? And so there are lots of things that are really small that I work with every day. The benzene molecule, for example, is just 6 carbons. It's extremely small, but it has no nano properties. Okay, it just acts as a molecule. But there are things like in inorganic chemistry where if we make a big cluster of atoms, it behaves one way, and when we make a really small cluster of atoms, it behaves very differently. Where might you find nanotechnology in your everyday life right now? Computers, right? There are some nano devices that are actually being utilized in some electronics. Yep, absolutely. But not all electronics are nano. Okay. Where else? military applications. There are certainly military applications that are nano-based. There are a number of materials that are nano that you may not even know are nano. Certain paint pigments that you all take advantage of use nanoparticles. And it's those small, tiny particles that give rise to the different colors. There is nanomedicine. How do we use small, tiny particles that we can use to deliver either a drug to a target cell, or it in itself is the medicine? So there are these things called gold nanorods, and they don't even look gold, but they're made out of gold atoms, and they're really tiny. But when you shine a laser on them, the quantum effects heat them up. And so you can actually then deliver those to a cell, blast it with a laser, the nanorods heat up and destroy the cell. Kind of interesting technology. So it spans the whole range. If you've ever seen copper fit bandages, right? You've probably seen Brett Favre advertise those on television. It uses nano copper. Does anybody know what is so special about the copper fit technology? Any athletes in here that use them? No? Well, it turns out that if you wear bandages after a while they start to stink, right? It's collecting your sweat and blah, 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 blah. The copper actually oxidizes those stinky compounds so that doesn't smell. But you can't just stick a piece of copper metal in there. You have to have very finely divided nano-level copper atoms impregnated throughout the material for that to work. And so things like copper fit and all those things actually make use of a level of nanotechnology. What kind of degree do you think you need to be a nanotechnologist? Think you can leave with your bachelor's degree and do that? You might be able to function as a technician in the field, but probably not going to have the label of nanotechnologist. You're probably going to have a master's degree or higher to get land a really good job in the nanotech industry, because again, those technologies require you not only to have a knowledge of chemistry, but very good knowledge of physics and mathematics as well, because we're dealing with things that are on the quantum level, really. What else do we have? You guys. Pardon? Chemical engineer. Is that going to be traditional or non-traditional? It's kind of a traditional. In a way, though, it's kind of non-traditional for a chemist, right? When I go into my laboratory and I set up experiments, I could care less about the engineering of it. I'm looking for a flask and some things that fit, right? But a chemical engineer is going to be concerned with how you pipe things from one area to the other, mass flow, heat transfer. You know, I don't really worry about that. I stick my flask in a bucket of ice so that it doesn't get hot, but a chemical engineer really has to worry about it. So as a chemist, if you ended up wanting to go in the chemical engineering route, what are you going to have to do? Probably go to grad school in chemical engineering and at least get a master's degree in chemical engineering, which is possible. So it's kind of traditional, but it's non-traditional in a way. What would be similar to a chemical engineer, but be traditional for a chemist? Pardon? Thermochemistry? Yeah, but I wouldn't call that a career. So last week we had a video that you all watched about process chemists, right? So a process chemist would be, in a way, related to a chemical engineer, but not an engineer. So if you're thinking about how could we take a process that somebody like me developed in a laboratory on a very small scale. You know, I do reactions on a gram, maybe 2, and to me that's a large-scale reaction. But if you're trying to move that into a process, into a company where you're actually going to make enough product to sell and make a profit, you got to figure out how to take that, what I did on a small round-bottom flask, and scale it up to a reactor that can give you a reasonable quantity of material. And process chemists and chemical engineers kind of share that space a little bit, but engineers are more on the engineering side of it, whereas process chemists are a little more on the chemistry side of it. You will typically find process chemists, in my opinion, in smaller startup companies. where they may not be worried about building a huge plant, but they're more concerned with building what we call a pilot plant that you can order and have delivered and put in a small room like this, where you're maybe making a kilogram or two of your material every day. And there are some materials and drugs especially that are so valuable, a kilogram a day could keep a company going. Because think about what you pay for your medicines, right? And you typically take medicines, pills are typically a 5 milligram this or a 10 milligram that. So a kilogram all of a sudden can make a lot of pills, right? So there's a lot of small chemical therapeutic companies that actually work on not ExxonMobil's kind of scales, but much smaller scales where process chemists can work. Back to this group. Give me another one. Pharmacologist, where would you put that? In traditional? What do you know about a pharmacologist? Okay. So my wife, you all will probably get to know her as you move up into the higher chemistry courses. She'll be teaching your analytical labs and your PChem labs. When she was at Vanderbilt, when we were at Vanderbilt, she worked in the med school in the Department of Pharmacology. So she was a chemist, an organic chemist by training, and actually did pharmacology research. And they did exactly what you just described. They took certain drugs and they fed them to rats and bacteria and other things and tried to determine how things were metabolized, where they ended up, all that kind of stuff. So it was a lot of pharmacology. They were actually trying to still figure out how Tylenol worked. Believe it or not, we still don't know exactly how Tylenol works, even though it's well over 100 years old. We do know that it's very toxic. You can actually get lethal doses very easily of Tylenol. And it's amazing that in this country Tylenol is actually an over-the-counter drug, because in many countries it is not. The effective dose and the toxic dose are very close to one another. So think about that the next time you decide to pop some Tylenol. Don't take Tylenol with beer. Don't use Tylenol with a lot of fatty foods. And don't overdose on Tylenol, because it will kill you, and there's nothing they can do if you take a toxic dose. So, but yet it's over the counter. Interesting enough. What else? Patent lawyer. Where would you put that? Patent lawyer. Okay. Is this something that you can do after you graduate with your chemistry degree? No. What are you going to have to do? You're going to have to go to law school, right? You're going to have to go to law school. So that can definitely be accomplished. I know several people who have gone on with their chemistry degree and worked in the patent industry. To be a patent lawyer, you have to go to law school. But if you're interested in patentable stuff, does that mean you have to go to law school? It does not. A fellow that I went to graduate school with, he was a few years my junior. We got together a few years ago for the retirement of one of well, actually, he was my wife's thesis advisor, but he was on my PhD committee. He was retiring. And this guy, he works at the patent office. So he's got his PhD in chemistry. He works at the patent office, and what he does all day is look at people's inventions and tries to determine if they're novel and patentable. Makes a good living doing that. So you don't have to necessarily be a lawyer to work in the patent business. But if you're not a lawyer, chances are you're going to have to work for the patent office, because a company's going to want you to be a patent lawyer so that you can put things together. I've worked with a patent lawyer before who was a chemist. They do know their chemistry. They sit down with your invention and they help you figure out if it's patentable, and then they start writing the patent, and they go nuts. They really do. They start talking about things that it might be useful for, and you're like, I hadn't even thought about that. Well, we got to protect your patent, So they do a lot of that. So that's a good one. What else do we have in the non-traditional realm? Let's pick over here. What did you all get as a non-traditional? Pardon? An accountant? And how would a chemist transition into accountant, and why would that be useful?
They have enough courses to qualify for it. Actually had a friend do that. She's a chemical engineer.
Mm-hmm.
She worked in the field for about 5 years and she switched to accounting. She got a job.
Okay. Yeah, and so oddly enough, I know somebody in the same boat. So my PhD advisor, his significant other was a PhD chemist, and she worked at the university for years, working in a biochemistry lab, and one day just got tired of it and decided to use her benefit at the University of Oklahoma and take free classes, and got involved in accounting, got her accounting degree, ended up going and working for KPMG, which is a large multi-billion-dollar accounting firm, and ultimately then transitioned from the corporate world into government and is now a forensic accountant. What's a forensic accountant? They're the people who follow the money. An accountant at a company is going to take care of the company and their books, right? And I'm using very loose terms. I mean, but a forensic accountant is going to figure out how you're cheating, right? And so that's what she does all day, is she looks at tax cases where they think that corporations are cheating or big individuals are cheating, and they go down that rabbit hole. So she uses her skills in problem solving every day that she learned as a chemist her entire life, even though it's not chemistry. So definitely a problem solving kind of thing. What else we got? Pardon? A sales engineer? What is a sales engineer?
Someone who uses the knowledge of chemistry to give to the product in front of a
Okay. Okay. So there's a lot of people that actually get a chemistry degree and do end up in sales of some sort. So we can say sales, sales engineer, whatever you want. There are a number of folks who will actually go on and work in sales for pharmaceutical companies. So a fellow that was in my lab as a graduate student got his master's degree and ended up going into sales with a pharmaceutical company. How would your chemistry skills be translatable into sales? Okay, so you're dealing with chemical compounds like drugs, therapeutics. You know the language, right? You can go talk to people at the company you're working for and understand what it is they're talking about. You can then try to break that down into simpler terms for the customer, right? So if you're wanting to go this more sales route, what might you want to do now if you're thinking about it? Yeah, I would suggest think about taking some business courses, maybe getting a minor in business, take some courses on sales. Accounting would be accounting has nothing really to do with sales, but you can definitely maybe take a couple of marketing classes, get those types of skills. Definitely you're going to want to work on your soft skills in many of these non-traditional careers, right? Your traditional careers, scientists typically, a lot of times, even though we do work in groups, we can be kind of oddballs in a room somewhere doing our work. But on the non-traditional side, you're out having to deal with a variety of individuals, right? And those soft skills start to play a major role. What else we got? Give me another traditional or non-traditional. A researcher. Yeah. So can you become a researcher with a bachelor's degree? Depends on what kind of researcher you want to be. Do you want to be the person that does the research at the lab bench, actually with the hands-on stuff all day? Yeah, you can become a laboratory technician and you can be involved in the research enterprise with a bachelor's degree. I've had people that have come through my lab get their bachelor's degree and go and work for Georgia Pacific, for example, and they do Georgia Pacific things all day long. They test products, they make sure they're not dumping things into the river that they shouldn't be, the whole 9 yards. Okay, so yeah, you can do things like that. But if you want to lead a research team, you want to have some people that work with you or under you, if you want to have people who, if you want to be the person that actually helps determine which projects are going to be advanced and moved on to the next stage in the company or the corporation, you're going to need an advanced degree, at least a master's degree, but most probably a PhD. So you're thinking about kind of the traditional route there. What else? Over here. Forensic toxicologist. Let's just call it forensics. All encompassing, right? Tell me a little bit about that. Okay. So
They study certain things like what was the last thing you ate before you died, like stuff like if you're on any drugs or if you were poisoned and stuff like that.
okay. Can you do that with a bachelor's degree? Maybe. You could get a job at a lab, especially a state lab, work your way into it, get the experience. But chances are you're probably going to have at least a master's degree, especially if you want to run the show and not just be a technician. But again, a lot of technician level jobs you can get started in at the bachelor's degree level. What else? A teacher. Would we call that traditional or non-traditional?
I would call it either.
Okay. So we'll kind of put it in the middle. Let's do that. We'll cheat a little bit. What do you mean by teacher? Are all teachers the same?
You have certain levels of teaching.
Okay.
Like a teacher for high schoolers, you don't even know if it's college as you as a teacher for college or a professor.
So a high school level teacher, right? All right. So will you all be able to get your chemistry degree and go work at Oak Grove High School the next day? No. In fact, I am not qualified to teach high school. And I have a PhD in chemistry. There's this thing called licensure that the state requires that you have. You have to pass certain things. There is a traditional path for high school teachers in chemistry, right? You study chemistry, you study it in our licensure program, none of which, if I recall, none of you are on that path. And you take some courses in education, you do your student teaching, you take an exam called the praxis, you do all these things, and at the end, when you've done all those things, you have a state license that allows you then to be entered into a classroom and allows you to teach. There's also a non-traditional route to become a high school teacher. And in fact, you can just have your bachelor's degree in a science. It's called the emergency route. I think they call it the emergency route. I had a student who was on track to go to medical school, could have gotten into medical school, but he kind of had a religious conversion at one point and wanted to spend more time with his wife and child, and he wanted to run youth ministry. And that's not particularly compatible with the life that you would have in medical school. And so he decided early in his senior year here at the university to switch career paths and decided to teach at the high school level. Hadn't taken a licensure course, none of that. Went out, got a job through this alternative pathway, and is currently taking courses to apply towards his master's. So he has an emergency license that allows him to teach, and as part of that, he's promising to take and complete so many courses at the master's level and get a master's degree. So there are multiple routes to that. So if you're not in the licensure right now and you decide as a senior, I don't want to go to med school, I don't want to do this anymore, I want to go and I want to teach high school students, then that's fine. So you can there's another way to get there, is what I'm trying to say. College level, I heard somebody say college. The difference is, even though I do view myself as a teacher, most professors do not call themselves teachers. I don't know exactly why we're that stuck up about it, but we are. We like to say we're professors, and we are professors. I mean, that is our title. We are a professor, and so we're qualified to teach folks at the college level, but we better not go into a high school and try to teach a class because we're not qualified. And it seems kind of weird, but it's true. So we do get invited to come to high schools and talk about things that we do. I get invited to go talk to a high school at least once or twice a year. Some of you may have been in some of those for some professors that have come and talked to you about various things. So teacher is a route that can is kind of a traditional route. If you're talking about college, it is a traditional route for somebody to go with a chemistry degree, get a graduate degree, do a postdoctoral stint, and then go into academics, as we say, at the college level. But that's going to be more for if you have a research agenda, if you really want to do some type of research. There are college professors who are at non-research institutions. Smaller liberal arts colleges don't have as big an emphasis on research. And so if you're thinking about teaching at the college level and you want to be at a smaller four-year liberal arts kind of college, you will still have a requirement of doing research of some level, especially with undergraduates. But you will not have the demands on you that you would have like at an R1 institution like us. Here, not only do you have to get a job, you have to actually pay for yourself in a lot of ways. So when I was just doing the faculty side of my job, I had to teach, I had to write grants, I had to get those grants funded, I had to pay graduate students, I had to buy laboratory supplies out of that money, and I had to pay myself in the summer because I'm only on a 9-month contract. So as a faculty member, we're only paid 9 months out of the year. And so to do the research in the summer, you had to find your own money. You had to write a grant to get that. And I had to publish. So you had to do all of those kinds of things. You had to get invited to give talks at meetings and universities, and all of that goes into being a R1 level college professor. If you can't do that, and if that doesn't appeal to you, that is definitely not a track you want to go on. But if you like working with students that are a little more mature than high school students, which a lot of people do, you can definitely become a professor at a four-year liberal arts kind of college where your main objective will be to teach and do a little bit of research, but usually there's not the pressure to publish and the pressure to get external funding for your work. All right, what else might we have in the non-traditional side? Safety inspector. Okay, that's good. So in the safety realm, you could definitely use your chemistry knowledge to be a safety officer or a safety inspector. Every company that deals with chemistry at all has to have somebody on their staff that is safety trained. That does not mean that your sole job duties are to be a safety officer, but when you get to a company that's big enough, like let's say something like a Georgia Pacific, you definitely have to have one or more people that's their full-time job. And so a knowledge of chemistry would definitely be useful because you're going to have to train employees on how to handle chemicals. You're going to have to train employees on how to deal with emergency situations that might arise. Do you think a chemistry degree is sufficient enough for this type of a job, though? You're going to need a little more training. So a chemistry degree will get you probably 80-90% of what you need, but when you take a job like that, you're going to have to go and get trained on other things in safety because there are things that deal with safety that aren't necessarily chemical. Plants have things that move, things that can grab your arm, your clothes, and pull you in. I mean, there's all kinds of things that you would need to know other than just don't throw lithium in water because it explodes kind of thing, okay? So, yes, you're going to need to know your chemistry, but you're going to need to know a little more than that as well. What else we got? A science writer. So let's just call it writing, or writer. Absolutely. There's a lot of people that take that non-traditional route. So if you have a love of writing, especially technical documents, this is an opportunity for you. A lot of people that have those kind of skills, though, I would argue probably go the patent lawyer route because that's a lot of technical writing as well. But there are a lot of opportunities for folks to become writers with a science background. So I'm affiliated with this organization called the Society for Science and the Public. They hire tons of science writers or employ a lot of freelance science writing because that's what they do. They educate the public about what's going on in science. They need people that can take the primary literature, the tough stuff to read, and distill it into easier stuff to read that a high school student or a high school teacher or just a regular layperson could understand and get some value out of. You definitely don't want somebody like me writing that. It would not go over well. So people who have writing skills will typically take that path as well. Anything else? We've got one more minute. Okay. There is actually a very famous chemist. His name was Carl Gerasi. He's dead now, but he lived to be quite old. He actually took probably the most non-traditional route to chemistry of anybody I ever knew. He worked in Mexico for a while and actually was the father of the birth control pill. He developed that technology, made a ton of money off of it. Is actually in the 60s and 70s was called the father of the sexual revolution, truly. And ended up leaving that company and went to Stanford to be a professor and studied for years. And then, I believe because his daughter committed suicide, and she was an artist, he just gave up on chemistry altogether. And stayed at Stanford, interestingly enough, and wrote plays about chemistry, wrote poetry about chemistry, has a fairly famous book that he wrote that it was fiction, but it had to do with some risque thing going on in a lab. I've never actually read it. I didn't really much care for his art. But he actually started a artist. He had this big ranch because he made a ton of money with his drugs. He took this big ranch and made it an artist's refuge. So he brought in artists from all over the country that were starving artists, gave them a place to live, and they did art for the rest of his life. And so he was, it's kind of interesting, kind of weird, but definitely a non-traditional route to a career. Let me see if Miss Carly's here. Hey, there you are. Come on in. Do you need to project anything?
Yes.
Okay. You have your computer?
I do also send you the link. I don't know if that would be easier.
Okay. Well, this is our Chemistry 108 course. It's a new course. It's about being the major, pretty much. And so we just talked about a little bit today about Goldwater. I did not get a chance to talk to them about Gilman at all.
Okay.
So they're a little bit familiar with that a little bit.
Mm-hmm.
So you sent this to me this morning?
I did.
There it is. What did it do? Oh. Okay, so I am, if you want to, you can use the mic. I'm recording. I mean, this is being recorded.
Oh, okay.
So I will let you take over.
Okay. Just click it here.
Yep.
Okay.
Yep.
All right.
So everybody, we're fortunate enough today to have Ms. Carly Causey coming to us to talk about nationally competitive programs. And like I said earlier, USM has been very, very successful with this, and I hope you all will strongly consider participating. We've got an excellent resource in Ms. Causey, and so I'll turn it over to you.
Awesome. Thank you. So as you said, my name is Carly Causey, and I'm the Project Director for Nationally Competitive Programs, and we'll get into what that exactly means in a little bit. But I know this is kind of an introductory course, but I do want to see who's in the room. So how many freshmen do we have? All freshmen? Okay, perfect. So I'll cover a lot today as far as kind of what opportunities are going to be available to you throughout your time here, and how you can be preparing for those as you're going through your undergraduate career.
But first I wanted to start with what nationally competitive programs are and what I do on a day-to-day basis. So nationally competitive programs are just that. They're nationally competitive internship, fellowship, scholarship opportunities that you can participate in and compete against scholars from across the nation to receive really cool honors, whether it be scholarships to study abroad, graduate fellowships to go pursue a PhD at your dream school, participate in an internship in Washington, D.C. or at the National Institutes for Health, which we'll talk about in a little bit. They are nationally competitive, and so they are this next level opportunity that you would be taking advantage of to put yourself on this national scale. But it's my job to help connect you to those opportunities and to help tell you how to make yourself competitive. And we'll talk about that in a little bit, how to make yourself stand out, how to create an application that is going to be putting your best foot forward and be successful in these opportunities. So that is what I do. You can see the bullet points there. It's pretty straightforward. But more importantly, what can you do? That's what we're here to talk about today. So your freshman year, we start with SMART, which you can see what it stands for there, but it's a really awesome opportunity to receive a full scholarship and be gainfully employed by the Department of Defense once you complete your degree. So it's kind of like a, what's the word I'm looking for? However many years they've helped fund your undergraduate degree, if you were to receive it, you then are expected but have the opportunity to work for the Department of Defense for up to 4 years. Can be more than that. And that can be deferred, like if that's something that you know that you're going to graduate school after your undergraduate career, there is a way to like extend that, and they can even help fund your graduate degree. But then again, you would work for them, you know, between 4 to 6 years, however long you're receiving it. So you do have to be pursuing a technical undergraduate degree in one of the 21 specified STEM disciplines. Y'all definitely fall within that, so that's not much of a problem. And if I show a deadline on here, I just want to highlight that that means we're still accepting applicants for it. And so if this is something you're like, oh my gosh, I've always dreamed of working for the Department of Defense, for a government agency, come see me and let's talk about if you want to apply this year. But SMART is something that you can apply for every year of your undergraduate career, and so it starts freshman year, but you won't see it on the next slides for like sophomore, junior, but it is just freshman and up. You just have to be 18 years old. So sophomore and junior year, we're certainly looking at a few more opportunities, a little more interesting opportunities. So there's a Holling Scholarship, which is funded through the National Oceanic and Atmospheric Administration. So I realize that you're chemistry, but maybe you have this kind of thread of wondering how to use chemistry to help the environment or to help the oceans in some way. That is what they're looking for. We've had actually a polymer science an engineering major participate in this, so that's kind of a side door into it. She was successful with it. But it provides that same academic assistance that SMART would, but then it also has you do up to two 10-week full-time paid internships at one of their facilities, which is a really cool opportunity. It is paid, which when you're looking at internships, you'll find that that's not always the case. So I know that Erin Crater, who is our polymer scientist that participated in the Holling, she was at their site in North Carolina. And so, but like that says, sophomores, it's just for sophomore year, and you have to have a 3.0 GPA, and the deadline would be January 11th. Next, we have the NIH scholarships, so National Institutes for Health. Those scholarships are targeting students that typically wouldn't have the opportunity to pursue this type of work, but they're also committed to careers in research. So I heard y'all talking about different careers that you can participate in as a chemist, and a research career is certainly one of them, and that you'll start to see a trend, and several of these are kind of geared toward that. The NIH scholarships, there's a variety of them, and so their deadlines vary, and some of those are, all of those are renewable for up to 4 years, so we're looking at that tuition assistance again. We do want you to have that 3.5 GPA. That is what makes you eligible, and then hopefully it is higher so that you're looking a little more competitive on that national level. And then I heard that y'all spoke a little bit about Goldwater earlier. So the Goldwater Scholarship is, again, that research-focused scholarship that is very competitive. It's the premier STEM research scholarship that we work with. Scholarship covers eligible expenses up to $7,500 annually, and you can apply as a sophomore and then as a junior. And so I encourage you to, if this is something you're interested in, if you're interested in pursuing a research career and you're like, I want to put myself out there for Goldwater, one, for sure get in a lab soon, and two, go ahead and apply your sophomore year. And it just makes it that much easier. If you're unsuccessful that first year, then that second year we're just priming and refining that application to make you more competitive and to show how you further engage in research past that. University endorsement is required, so like for this year, we if more than 4 people, so you can only put 4 people from your university to the national competition, and this year we have 5 people interested, so there is going to be this internal competition to see who's going to be our strongest candidates, and so we have a committee that reviews that, and then they choose to endorse the applicants they believe will be most successful. And so just knowing that sometimes there's an on-campus competition as well as before you progress to that national competition. And then we have the Udall Scholarship, which again has that environmental twist on it. So if you have an interest in preserving the environment in any type way, there's kind of a broad definition when they're looking at the Udall. That is what that application is going to be tailored to. And again, it's a scholarship for tuition and fees and helping cover your undergraduate education. And again, awarded for 1 year, but renewable for up to 4 or up to 3. And then sophomores and juniors are eligible. And so we don't have a candidate for that this year. So if you have a friend or you know someone that is like super passionate about the environment and super passionate about advocating for that, send them my way, because we certainly want to put forward an applicant for that, since we still have a little time until the January 30th deadline. And then senior year, I know y'all are far way off from it, so I just kind of hit the highlights on what opportunities are going to be available there. Most of these are going to be graduate fellowships, and so these are going to be things that you can apply for as a graduating senior, and then you'll also be able to apply for as a first, second year graduate student once you get into your actual program. The National Science Foundation for Graduate Research Fellowship Program, which is a lengthy title, we just call it the NSF GFRP typically, supports those students in STEM disciplines pursuing research-based master's and doctoral degrees in the U.S. And you'll find that, like, if you're a Goldwater applicant, then you're probably going to do NSF your senior year. If you did Udall, then you're probably going to do NSF or Hertz or one of those. And then another note on these is that a lot of these will work together to help fund your graduate program. And so like NSF, National Defense Science and Engineering Graduate Fellowship, and Hertz, I know for sure, they talk about how they coordinate to work together to help you pursue that graduate degree. And then I also heard y'all talking about the option, that non-typical route to maybe teaching with your degree. Maybe you realize not interested in going to medical school anymore. Then there's also the Knowles Science Teaching Fellowships. So they're looking for those teachers in secondary schools and willing to help fund your graduate work that'll help get you there. And then Fulbright, and I'll touch on Gilman as well. So there's also these opportunities for you to go abroad. I'm sure you've heard about study abroad here at USM. We're big proponents of it. And so one option is going to be the Fulbright U.S. Student Program. And so that is an opportunity to actually study at a foreign university. You propose a research project and you do a study research project with that foreign university. You design it completely on your own, and then you get to go. They fund your travel, they fund your time over there. It's a huge honor. It's very, very cool. We typically have, there's also the Fulbright English Teaching Assistant Award, so we're always interested in pulling from our STEM disciplines to find students to apply for the study research grants. And we have been successful in that previously, but it has been a little bit. And so the other side of that that Dr. Masterson wanted me to talk about is the Gilman Scholarship. So Gilman is for Pell eligible students to study abroad, and so and it can be applied toward any study abroad program here as long as it's credit granting. and it's not a super lengthy application. It's like 2 1.5-page essays, and then you just have to be Pell Grant eligible. And then the flip side of that, there's a new one. I don't know if any of you are dependents of active military members, service members, but there's the Gilman Scholarship that doesn't require the Pell Grant eligibility. It is just looking to see that you're a dependent of an active duty military personnel. And those scholarships are up to $5,000 to study abroad, and we've been extremely successful in those. So just some things to think about as you're kind of mapping out your undergraduate degree here and figuring out what you're going to do and what you have time to squeeze in. These opportunities that we've been through, they're a little bit different, they're a little bit specific, they're a little bit tailored, and so how do you become eligible and competitive? Figure out which areas of your discipline you're super passionate about. So a lot of these have like a specific kind of thread to them, the environmental or the research or the oceanic thread that they're looking for. And so you have to be familiar enough with yourself that you know what you care about in your discipline, what your goals are, what you're looking to do long term. And I know y'all are already having those conversations in here, and you're probably like, there's so many options, I don't know what to do. And when you come to me, you don't have to have that completely figured out. And so a lot of times students come to me and they don't know where they want to apply for, but we start talking about what your interests are, and where your interests lie, what those ultimate goals are, why those are your ultimate goals, and we can help match you to the program that is best fit for you. And then these processes themselves, they help you start thinking in this long-term mindset, in this very specified mindset of